meniscus is the curvature of the water when it is stationary.
It occurs because water has an adhesive property that basically causes the water around the edge of the beaker to stick to the beaker, and water's cohesive property, resulting in the surface hinge of the water, pulls other water molecules to the edge of the beaker with it.
You look at the bottom edge of the meniscus, and it reads to be about 200 milliliters.
So now I'm going to demonstrate like what it looks like a meniscus forming after you've taken liquid into a pipette. So see, now that there's liquid in here and I hold it flat, there's a slight curve at the bottom of the liquid, and that's where you're going to read what your measurement is here. So here I'd probably guess it's 3.08 milliliters of water.
Some certain amount of milliliters of this 20% sugar stock solution. This reads to be about 7.25 milliliters, and I'm dropping it in the volumetric flask. So now I am pouring water to this line right here to completely dilute. Just a little bit more. Okay. The result is a dilution of the stock solution that we used.
So here I'm about to take out some liquid from our 1.45% solution, which we just diluted from our 20% stock solution. So here we go. We'll say 2.52 milliliters going into our 100 milliliter flask. So this is our 1.45% solution, and I'm going to dilute it further with water up until we get to 100 milliliters.
Alright, so now we're going to dilute it with the 0.5% solution. That's good enough. 1.6 milliliters. And now this is the final dilution. Pull it up to the 100 milliliter mark. A stock solution is the given solution for an experiment with known concentrations that solutions of lesser concentrations are made of. A dilution is the resulting solution when a diluting solution is added to a solution giving a lower concentration.
Okay, so this is the equation to find your final concentration. You got M1, which stands for the initial concentration, V1, which stands for initial volume, and then it's equal to M2, which is the final concentration, and volume, which is the final of the dilution in the stock solution.
So for exercise 2, here's all of our calculations and data. So in order to get the mass of each solution that we had, we subtracted the mass of each container that the solution was in from the total mass of the solution in the container that we took on the balance to get the final mass of just the solution. Dilution 1, dilution 2, and dilution 3. And that'll come into play in the table down here later. And then also we wanted to incorporate the concentration, the calculation we went through to get it down in the table. We had the 20% stock solution. We put 7.25 milliliters of that in the graduate